We have two presentations to close off the last day of the Riyadh Industry Week International Summit. And I'd like to call up on stage Mr. Onur Yildiz, who is from a company called Alloy Additives. So this is an additive 3D printing company based in Turkey, exhibiting with us today. Mr. Onur, are you out there? Oh, here he is. Thank you. Please join us up on stage. You take over. I'll just sit on the sidelines. Thank you very much. Give him a hand, please. Thank you.
Hello everyone. So apologies that our founder Mehmet Çetinkaya is not here, so he had to catch an early flight. And I will be presenting our company, Alloy Additive. I'm the business development manager of the Alloy Additive. Actually, we are a deep tech company, metal, providing services for the metal 3D printing for the customers in the industries of aerospace, defense, oil and gas, as well as marine. And the current industry problems, as I mentioned, the industries that are facing with the traditional manufacturing methods are prototyping delays, which are causing extended R&D cycles, and material degradation also leads to reduced life cycles, and the spare part shortages, large inventories, with the result of high downtime costs. With all of these taken into consideration, we are also seeing that there is sustainability pressures coming out of all of those problems. So Alloy Additive is providing end-to-end solutions for its customers and clients, which are actually based on the large metal 3D printing area. And the solutions that we provide actually are the reverse engineering, digital inventory, on-demand manufacturing, large 3D printing, as well as the test and quality management of the final production. The value provided for our customers and clients are basically on the cost effectiveness. So apart from those, the longer product lifespan with the manufactured pieces and components by the Alloy Additives technology reduce downtime costs. We provide faster lead times, again, sustainable manufacturing with less material waste and lower CO2 emissions. Also with the digital inventory, we provide seamless integration to the current operations of the customers, and with the expertise of Alloy Additives on exotic metals and alloys, lightweight and high-strength materials can be utilized. So the technology and the equipment setup looks like this, and the most critical part here is that the 3D printing software that was developed in-house by our R&D engineers. As you can see, the equipment is wire-fed, and the robotic welding arm is working with the optimized tool path. Also, the software enables us to develop our own parameters, for process parameters, which are differentiating for each of the materials that we want to print to. As I said, the exotic alloys, we provide solutions with the titanium alloys, nickel alloys, copper alloys, and steel, with different types of steel. So the industries are aerospace, energy, oil and gas, marine, as well as defense. So we have a 3D printed part was sent to space, and it was a part that is used as a rocket nozzle extension. So there are some cases that I would like to show you. One of them is the one that was sent to space. The picture on the left-hand side, you can see that this is an image from 100 kilometers of altitude, and the material is 40% lighter than steel. There is a 60% lower cost, and the lead time was decreased from 7 weeks to 7 days, and this was also tested for static firing tests. The oil and gas industry also needs our services. This was the case for made for SOCAR, Azerbaijan oil and gas company. So the Venturi here you see is upgraded with our technology. So we upgraded for higher temperature and heat resistance. So now the downtimes are reduced significantly with this part. So again for SOCAR, we have provided them an impeller, stainless steel 316. And this is also, we are going to go into more in details with this part because we did a reverse engineering in order to produce the near net shape, and then afterwards we did the finishing. This is a grid fin application, undisclosed Turkish defense company, so used for rockets, as well as you can remember this from the Elon Musk's rockets, so they are using for directing and balancing the rockets. So this was with the material of Inconel 718. So the complex geometries also, we have the expertise to produce complex geometry with the hard materials like Inconel. So again, one of the largest aerospace and defense company in Turkey, Turkish aerospace company. We provided them a composite mold, and the mold also qualified for their for the client's test, penetrant test, dynamic vacuum leakage tests. And important here is the fact that the lead time was 3 months, and we did this successfully in 24 hours instead. This is for a French company, Alstom, railway company. We provided services for digital warehouse actually here. So immediate response by our team to produce this part so that the operations do not stop. Again, with the technology that we are using, which is called wire arc additive manufacturing, WAM is the abbreviation. So it has the flexibility to be used as for the repairments of the part. So in the other additive manufacturing, especially for metal additive manufacturing, it's nearly impossible to use the repairment cases, but with our flexibility, we can provide the service as well. So again, for the impeller case, so the left-hand side is the near net shape, and the right-hand side is the finished one. And here we can see that the original part, which was made by cast. And the right-hand side is again WAM impeller produced with alloy additives equipments. So here you can see the original part, and then with the reverse engineering, we get the 3D scan of it, and then we get the 3D print tool path, which is going to be used for the printing. So the case for this impeller is that it was manufactured in 1990. So in that year there was no SolidWorks, so that's why we have to use the reverse engineering in order to come up with the correct toolpath. Lastly, the results also show that casting had some defects on the product itself, on the part itself. So with the WAM, these defects are very minor, and with the X-ray results, we can see that you can see the porosities are all around the part in the casted version, but in the WAMmed part, the porosities are really minor. So that with the density ratio reaching to 99%, and the other one is less than 96, so it means that the higher density ratio results in higher lifespan of the parts, thus lowering the downtime costs. So this went also, there were some experiments and tests conducted on the part as well. and they were all successful to qualify for the use case application. I'm not going to go into so deep on these ones. And we have office in Istanbul, Technopark, one of the hubs for those kind of deep tech startups in Turkey. Very important, very famous one. And also we have an office in Aachen, Digital App Aachen in Germany. In case of any inquiries, please visit our website, send us an email or inquiry for the information. Thank you for listening.